Today we're going to learn to add and subtract worded problems. Oh, hey, Teddy. What are you saying? Teddy says that worded problems are like a story. I wonder what he means by that. Oh, I think Teddy's talking about first, then, now stories. Let's take a look at this story. Oh, look at the baby chicks. First, there were some eggs that hatched. How many chicks are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 baby chicks. Then, the next morning, some more baby chicks hatched. How many are there? 1, 2, 3, 4, 5, 6, 7. And now, we have a lot of baby chicks. But before we figure out how many there are, let's think about what calculation would we write. First, there were 9 chicks, then 7 more hatched, and now, I think this is an addition question. I'd write down 9 plus 7 equals something. I'm going to get you to pause here and count how many there are now. And when you're ready, come back. We'll see if we got the right answer. Okay, did you count them all? Did you find out that 9 plus 7 equals 16? Well done. What's happening here? Oh, good. It's another first, then, now story. Let's take a look at the pictures. Whoa, first there were some balloons. Oh dear, then something happened. It looks like some of them burst. And now, well, there don't seem to be as many there. What calculation would we write to represent this? I'm going to pause here so that you can have a go. Count the balloons, tell the story, and see if you can come up with a calculation. And when you're ready, come back. We'll check the answer together. Did you write down 12 subtract 4 equals something? If you did, you were telling the proper story. First, there were 12 balloons. Then, 4 of them popped. Now, did you figure it out? Well done! Now, there are only 8 balloons left. 12 take away 4 equals 8. Now we're going to look at a word problem, but this time we're going to use a part-whole model. Here's the story problem. There were 11 cookies in the jar. 6 cookies were eaten. How many cookies are left in the jar? Remember, this time we're going to do a part-whole model. In the beginning, altogether, there were 11 cookies in the jar. Do you know where we'd put the number 11 in our part-whole model? Did you think to put it in the whole? Exactly. That's how many there were altogether to begin with. But then 6 cookies were eaten. So we need to put 6 into one of the parts. And we don't know how many cookies are left in the jar. So we'll show that with a question mark. Now, let's think about what's our number sentence for this. How can we calculate how many cookies are left in the jar? Exactly. 11 take away 6 equals something. And what is that amount? How many cookies are left in the jar? Exactly. There are 5. 11 subtract 6 equals 5. So there are 5 cookies left in the jar. Now let's look at a word problem, but this time we're going to use a bar model. Have you used a bar model before? Let's read the question. Whitney has a bowl of fruit. There are 12 bananas. There are 4 fewer lemons than bananas. How many lemons are in the bowl? Well, once again, we said we could build a bar model for this. Let's think about what we know. We know that in Whitney's bowl of fruit, there are some bananas. Actually, there are 12 bananas. So we're going to draw a bar representing 12. It says that there are 4 fewer lemons than bananas. We can show the lemons, but the only thing that we know is that there are 4 fewer. We actually need to find out how many lemons are in the bowl. We're going to show 4 fewer with this arrow and the number 4. And we're going to show the lemons, which we don't know, in the other bar. So what calculations can we do? Well, our question says that she has a bowl of fruit and that she has 12 bananas. It says that there are 4 fewer lemons than bananas. But we don't know how many lemons. So 12 subtract the lemons would give us the 4 fewer. Is there another calculation we could write? Take a look at the bar model. That's right. We could do 12 minus 4 equals something. So what is 12 minus 4? Did you say 8? You're correct. Now we know that there are 8 lemons in the bowl of fruit. Well done. It's time for you to have a go. Let's look at the question. Jack bought a package of 12 pencils. 6 of the pencils are blue. The rest are yellow. How many yellow pencils are there? I'd like you to pause here and have a go. Why don't you try a part-part whole model or a bar model? Or better yet, why don't you have a go at both? Then come back when you're ready and we'll go through both solutions. Right. Let's begin. Let's begin with a part-part whole model. Is that the strategy you used? We also need to think about what calculation do we need to do. When you read through the story, what calculation were you thinking? Were you thinking 12 pencils, subtract the 6 blue pencils will give us how many yellow pencils there are? That would be great. But now let's fill in the part-whole model. Where does the number 12 go? Exactly. That's how many pencils there are altogether in the package. What about the blue pencils? Where would that go? Exactly. That's one of the parts. What we don't know is the other part. Those yellow pencils. Now let's take a look at a bar model. Here we have a bar with 12 equal boxes. Each one of those would represent a pencil. We know that 6 of the pencils are blue, so we can color those in blue. We also know that the rest are yellow, so we can show that here. We can even color them in yellow to make it even better. So how many yellow pencils are there? Can you count? What's your answer? Exactly. 12 subtract 6 blue pencils gives us 6 yellow pencils. I hope you had a go at both the part-part whole model and the bar model. It's time for you to have a go again. This time the story is about Rosie and Eva. They were playing beanbag toss. Rosie scored 4 more points than Eva. Eva scored 6 points. How many points did Rosie score? Why don't you pause here, think about your strategy, and then come back when you're ready. We'll see if we chose the same one. Right, here we go. Which strategy did you use to find out how many points did Rosie score? I decided to use a part-part whole model. Here's what I think. I think I want to write down the calculation first. I know that Eva scored 6 points, and I know that Rosie scored 4 more points than Eva. I want to find out how many points Rosie scored, so I can think of the question as 6 for Eva plus 4 more would tell me how many Rosie scored. Now, where will I put those numbers? Will they go in the parts or in the whole? Exactly. 6 goes here for how many Eva scored. We know that Rosie scored 4 more points, so that's another part. And if we add the two together, we're going to find out how many points Rosie scored. Do you know how many points Rosie scored? Exactly. Rosie scored 10 points. And we know this maybe because we remembered one of our number bonds to 10. 6 plus 4 equals 10. Excellent job. And now we're at the end of this lesson. Why don't you pause here and have a